Hey everyone, welcome back. So now we're going to do something a little more useful. So instead of mole-mole conversions, we're going to do mole-mass conversions. And why do I say it's more useful? Well, the answer is in the lab, we normally work with masses. We weigh things on a balance, so we can't easily put something on the balance and figure out how many moles it contains. Well, we have to do a calculation, but we can tell how many grams something has. So here is a question for us to ponder. So the question is, how many moles of water do we make from, okay, I was just saying moles are pretty useless, from say 454 grams of C3H8, and that is a pound of propane. So, oh wait, we're not working with propane, are we? We're working with C2H6, my bad. So how might we do a problem like that? So this is one where when I first started learning chemistry, I thought, oh my gosh. So I don't know what that was. Oh my gosh. So how do I figure something out like that? Well, we know how to convert between grams and moles through the molar mass. And now we know how to convert between moles and moles using the coefficients. So we have to put those two things together. So I like to think of this as mole city. And I've got two layers or two roads going through mole cities. I've got my moles and I've got my grams. And my moles sit, if you like, directly underneath my chemical equation. And the ratio of moles is given by those coefficients. The grams are not directly used by the equation until I turn them into moles. So I've got to turn my grams into moles, and then moles into other moles, and moles into grams. So it's kind of like that. And if you like, I've got a barrier in the middle, so I can't easily get from one place to the other. So in this problem here, what am I doing? I'm essentially starting with grams of C2H6, and I have to convert them up to moles of C2H6, and then I need to convert them to moles of water. So I can't go through this barrier right here, this brick wall. So here's how we're going to do this. So first of all, apologies for my art. Art was never my strong point. And I'm going to make a plan. So my plan is I'm going to start down here in Gram City or Gram Road with 454 grams of, if I can spell it right, C2H6. And I can convert that to a certain number of moles of C2H6. That's going to be step one. And then I can go ahead and I can convert that into a certain number of moles of water, and that is going to be step two. So this is a two-step problem here. How do we go from grams to moles? Well, we have to use the molar mass. So what we need to do for the first part, right, is we need to find the molar mass of C2H6. Because it's going to give us the number of grams there are in 1 mole. And how do we do step 2, moles to moles? We're going to use those coefficients in the balanced chemical equation. So if it's not balanced right, we got to go back and balance it first. So let's go ahead and do step 1, and then we'll do step 2. So I'm going to pick another color here. The molar mass. So we've got C2H6, right? That is made of 2 carbons and 6 hydrogens. On the periodic table, carbon will have a mass of 12.01. Depending on the table you look at, you might have fewer or greater digits, but we're just going to go with that for short. Hydrogen has something like 1.008, and roughly speaking, we're adding, so we can't go past the second decimal place here. The rule of addition, right, is we can't go past the fewest number of digits we've got after the decimal point. So if we multiply that out and add that up, we get, let's see if I can do this math here. So 30.07, and what is that? That is the number of grams there are in a mole. So we can do this very first step now. And let's go ahead, and before we put it all together, let's do step 2, the coefficient. So we basically just have to point. So there's 2 moles of this to 6 moles of that. So let's just go ahead and write that molar ratio out. So 2 moles of ethane, or C2H6, begets or produces 6 moles of water. So now we are ready to go ahead and rock and roll. So down at the bottom, we can go ahead and we can train track the heck out of this. We can take our 454 grams of C2H6 and we can convert. And here's a nice trick, right? Instead of writing the conversions as individual multiply by fractions, we can just do train tracks like so. We multiply everything on the top and we divide through everything on the bottom. So what do we want to do first? We want to convert grams to moles. So we have to put the number of grams on the bottom, And a very good habit to get into is to say the grams of C2H6 and not just grams. Otherwise, our units aren't going to be there for us to catch mistakes with. So let's cancel as we go. So grams of C2H6 cancel. We're now left with moles of C2H6, and we can convert moles of C2H6 into moles of water. That's just what we did in the last lecture, I believe. So how do we do that? We look at the molar ratio. So 2 moles of C2H6 on the bottom, so they cancel, gives us 6 moles of H2O on the top, so that they are left behind. And again, moles of C2H6 cancel out, and we're just left with moles of water. And if we go ahead and plug that in on our calculator, and at the end of the day, right, we're going to have as many significant figures as the worst measurement. So that has 3, and everything else has 4 in the case of 30.07. It's infinitely exact in case of these numbers here. So our worst one here is 3 significant figures. That means the answer must be 45.3 grams. It would help if I'm not on the eraser tool. So 45.3 with rounding. It's actually 29 grams of, what is it again? Oh, it's water. Okay, so that's why. I almost said C2H6, but I wasn't paying attention to my units. So, wow, that was kind of a long problem. So I'm going to go ahead and go to another slide. And then I'm going to let you try it, and then we'll go through it together. And if you want to just skip that and move on, you're welcome to. So see you in a bit. Apologies, I snuck in early and wrote this problem up. So let's go ahead. So here's an unbalanced equation, nitrogen plus hydrogen. Remember those 2 of the 7 diatomic elements. They form ammonia. Ammonia is a molecule whose name is systematically nitrogen trihydride, although you have to know it as ammonia. And the question is, how many grams of ammonia can be made from 2.7 moles of H2? So in order to do this problem here, right, well, okay, pause it, and I'll give you a little hint here in a minute. If you get stuck, listen to it, and then try the problem, and then we'll compare notes. So, okay, are you ready for the hint? And the hint is to consider mole city. So on the bottom here, we've got grams, and on the top here, we've got moles, and there is a wall down here between grams of one side and grams of the other. So all we're going to do is get from one side to the other. So how many grams of ammonia means we got to get down here, and we're starting from 2.7 moles of hydrogen, so we're up here. So we would go from here to here, and then down to here. Okay, that was your hint. Yeah, it wasn't much of a hint. Okay, so if you get stuck again, well, I'll do one more thing, and then we'll just go through it. So you ready? All right, so the first thing we need to do is balance the equation. We can balance it by placing a 2 here and a 3 here. So we've got 2 nitrogens on each side, 6 hydrogens on each side. So, okay, so now we should probably put the plan out. So we have 2.7 moles of hydrogen. So we start up here in mole city, 2.7 moles of H2, and we need to convert over here. So we know that we're in the mole lane, so we can get 2 moles of NH3, and then we can sneak down here and get to grams of NH3. And this is a 2-step problem, so just like before. And the question is, how do we do each step? Well, moles to moles, we just use the coefficients in the balanced equation. And moles to grams, moles of one thing to grams of that same one thing, we use the molar mass. So we're going to have to find the molar mass of NH3. So we should probably do those 2 things down at the bottom. So I'm going to go ahead and look at the coefficients. I'm just going to get my pointy fingers out. So my pointy finger says 3 of these, 2 of these. So I can just say 3 moles of one, that is the hydrogen, produces 2 moles of the other, that is the ammonia. And then the second thing I need to do is find the molar mass. Now, even though there's a coefficient of 2 in the balanced equation, the molar mass is the mass of just 1 mole. Okay, so don't worry about the 2. We just got 1 here. So we got 1 nitrogen, 3 hydrogens. Nitrogen is 14.01. Hydrogen is 1.008. And we add that up. That is 17.04. What are those units? So that is the number of grams 1 mole of ammonia weighs. So we can put it all together now in the last step of the problem. So I'll do this in green. So what do we have here? We've got 2.70 moles of hydrogen. And instead of train tracking it, I'll write it out in full. And we use our coefficients. So there's 3 moles of hydrogen that go in, and out come 2 moles of ammonia. And we cancel our units. Okay, now we got moles of ammonia. So the very last step is to convert that into grams. So we know our molar mass. 1 mole of ammonia weighs 17.04 grams of ammonia. Okay, so we didn't have to worry about the 2 because the 2 is taken care of right here. And if we put this together on our calculator, we should get the answer. And remember, the significant figures is determined by that first measurement. 2.70 has how many? That's right, 3 sig figs. So on our calculator, we need to round to 3. That gives us, oh, got one more little thing, got to cancel those units. So that gives us, let's see, 30.7 units are grams. And what are we working with? We're working with ammonia. So that's how you did that. So if you got that right, congratulations, well done. You are a chemistry genius. And if you got that wrong, go through the video again and try another one, and or try it again and see if you get it better this time. So well done either way, and let's move on.